Today we're doing Lab 27 organic chemistry models. We are moving from inorganic chemistry to organic chemistry, where we are looking at carbon-based molecules. These are the molecules that make up living creatures, that make up our fossil fuels, and plastics. So first I want to go over our basic atoms. We are working with hydrogen atom, which here is our model is white, and it shows that one peg that it has the ability to have one covalent bond. Our oxygen is red and has the ability to have two covalent bonds, and our carbon is black with 4 pegs, so it can have 4 covalent bonds. All right, so on page 159, we're going to be working with this table here. And you can see that these are all composed of 2 carbon atoms, 6 hydrogen atoms, and then we start putting in some oxygen molecules. These 2 here, you can see that they have the exact same chemical formula, however, their structural formula is different. This one has an oxygen in the middle with a hydrogen at the end, where this one has a hydroxyl group at the end. This is called an isomer when you have 2 identical chemical formulas. All right, so let's look at these. So I have ethane, dimethyl ether, ethanol alcohol, and ethylene glycol. So when we look at ethane, ethane is composed of 2 carbon atoms held together with a covalent bond, and then they're bonded with hydrogen atoms at the end. Dimethyl ether is very similar in structure, however, it has an oxygen between the 2 carbon atoms. Ethanol alcohol, again, is like ethane, however, we have swapped out a hydrogen atom for a hydroxyl group, and you should know by now that a hydroxyl group is an oxygen and a hydrogen together. And ethylene glycol has swapped out 2 of the hydrogens. Remember, it's just like this. 2 of these hydrogens have swapped out, and in its place we have these 2 hydroxyl groups. All right, so now let's look at whether these are polar or non-polar. So there are other groups that can make something polar, but for the simplicity of our lab, we're going to say that when you have a hydroxyl group, again the oxygen and the hydrogen, then that's what's going to help make things polar here. So when you have a polar atom, what makes it polar is the imbalance between the charges. So we've learned that the oxygen is very greedy and likes to take that electron and take it more than it allows the hydrogen to have it. And so that creates a more negative charge with this atom. And then because its electron doesn't have it very often, it has a more positive charge. So this imbalance between this group is what creates a polar molecule. Okay, so if we look at ethane, they have the same electronegativity, the carbon and the hydrogen. So they share equally the covalent, the bond, or the electrons, they share equally between the 2. So this is a very happy molecule, and its charge is very stable. So this is non-polar. We're going to skip this one for now. We look at this one, we know it has a hydroxyl group, and we know a hydroxyl group is polar because there's this imbalance, making this molecule now a polar molecule. When we look at ethylene glycol, of course now we have 2 hydroxyl groups, and so this one is definitely polar. But what about this one? Well, we have an oxygen here. It happens that the oxygen and the carbon have the same kind of relationship like a hydroxyl group. in that this is more electronegative. This again likes to hog the electron. And so this creates an imbalance. And so this is also a polar molecule. So what about hydrogen bonds? All right. Again, we're saying there are other things that can create hydrogen bonds, but for this lab and for you, we're going to say we have to have a hydroxyl group to create a hydrogen bond, meaning the oxygen needs to be bonded to a hydrogen here. Okay, so when you have hydrogen bonds, then that makes a molecule soluble, and you'll also might see the word miscible. Okay, miscible means scientific word for soluble. So if we look at ethane, again, ethane is very stable between sharing. There is no